Space may seem empty, but it's full of gas and dust. These cosmic clouds, called nebulae, are the birthplaces of stars. Gravity pulls denser regions inward, forming a spinning cloud. This forms a protostar, which grows hotter and denser. Nuclear fusion begins, and a star is born. The birth of a star is a dramatic event. Imagine a cosmic explosion, but instead of destruction, it creates something new and radiant. The energy released from nuclear fusion creates an outward pressure that balances the inward pull of gravity. This balance, a delicate dance between two powerful forces, is what defines a star's life. The newly formed star, now a blazing ball of plasma, settles into a stable period of its life. This is the main sequence, where a star spends the majority of its existence. Our own sun is a main sequence star, about halfway through its lifespan. The size and temperature of a star determine its color and brightness. Hotter stars burn with a blue-white light and are incredibly luminous. Cooler stars emit a reddish light and are less bright. Our sun, a relatively average star, glows with a yellow-white light. The main sequence is not a static state. As a star fuses hydrogen into helium, it slowly loses mass. This loss of mass affects the star's gravity, causing it to expand slightly and cool over time. This process, though gradual, sets the stage for the next chapter in a star's life. Stars spend millions, even billions of years in the main sequence, but eventually their hydrogen fuel begins to run low. The core, now mostly helium, can no longer support nuclear fusion at the same rate. Gravity, always present, begins to gain the upper hand. As the core contracts under gravity's pull, the outer layers of the star expand outward. The star swells in size, becoming a red giant. Imagine a balloon being inflated, its surface stretching thinner and glowing red from the heat within. Red giants are cooler than their main sequence counterparts, hence their reddish hue. However, they are much larger and more luminous. If our sun were to become a red giant, it would engulf the orbits of Mercury, Venus, and possibly even Earth. For some stars, the journey doesn't end as a red giant. Massive stars, much larger than our sun, evolve into supergiants. These stellar behemoths are the largest stars in the universe, dwarfing even the largest red giants. Red giants and supergiants are stars' twilight years. As a red giant or supergiant continues to evolve, its core becomes incredibly hot and dense. The helium, a byproduct of earlier hydrogen fusion, now becomes fuel for further nuclear reactions. Helium fuses into heavier elements, such as carbon, oxygen, and even iron. These nuclear reactions release even more energy, temporarily counteracting gravity's relentless squeeze. However, this is a losing battle. The star's core continues to contract, and the nuclear reactions become increasingly unstable. The fate of a star now hinges on its mass. Lower mass stars, like our sun, eventually shed their outer layers into space. This creates a beautiful expanding shell of gas called a planetary nebula. The remaining core, a white-hot ember of the former star, is called a white dwarf. Massive stars, on the other hand, meet a more violent end. Their cores collapse so rapidly that they rebound in a cataclysmic explosion known as a supernova. Supernovae are among the most energetic events in the universe, briefly outshining entire galaxies. Stellar corpses, white dwarfs, neutron stars, and black holes. After a supernova, the core of the massive star is compressed to an extraordinary density. Depending on the mass of the core, it can become either a neutron star or a black hole. Neutron stars are incredibly dense, packing the mass of our sun into a sphere only a few miles across. Black holes are even stranger. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a bottomless pit in the fabric of space, where everything that falls in is trapped forever. The life cycle of stars is a story of birth, life, death, and rebirth. The elements forged in the hearts of stars, scattered across the cosmos by supernovae, become the building blocks of planets and even life itself. We are all made of star stuff, connected to the vast universe by the intricate lives and deaths of stars.